find something to amuse myself. Police cruiser is approaching a right-angled intersection from the north. Okay, so like going this way from the north. And it is chasing a speeding car. So let's say this is the intersection. That turn the corner in is now moving straight east. Okay. All right, so when the cruiser is 0.6 miles north of the intersection, so I'm giving us this, and a car is 0.8 miles to the east. The police determined the radar that the distance between them is increased at a rate of 20 miles per hour. So the distance, this is going to change, all of these are going to change, right? But let's say the car is here and here. Isn't the distance between them, the shortest distance would be that line right there. So what we have is a triangle here. And so when I'm deciding what formula I'm going to start with, notice what I'm asking you to find. The speed of the car. So this does not involve a rate of change of an angle. And when that's the case, then we're going to really use Pythagorean theorem. Okay? And so I'm going to go ahead and I'll make this x, because it's like my x-axis. This is y. And then I'll just call this, I think our book called it D, the distance between the two cars, or maybe D for the diagonal. Okay. I'm going to highlight some things. The distance between the car, that would be the police cruiser, is increasing at 20 miles per hour. The cruiser is moving at 60 miles per hour. Let's see. The cruiser is 6.6 miles north, and the car is, all right. So let's write our variables down and at least write the relationship between x, y, and d. What is the relationship between x, y, and d?
X squared plus y squared equals d squared.
Yes. Now, because we're dealing with rates of change, we're going to take the derivative. But before we do that, let's write down what we know and then what we don't know. What is this?
Y.
All right, and now I don't put y in right now because is y something that's going to change? It is. And so I'm going to wait to put it in at the end. If it never changes, you can put it in at the beginning. The reason why is because otherwise, if you would put it in now and you take the derivative of 0.6 squared is 0, and you'd forget about that dy dx, and we need it, or the dy dt, and we need it in there. Are you told dy dt? This is a cruiser, right? What's the speed of the cruiser? Now here's the deal though, it's moving towards the intersection, so we're going to actually call that a negative 60 miles per hour because this distance is getting smaller. Okay. All right, how about x? Do we know x? It's going to be 0.8. Do we know dx dt? Speed of the speeding car? Nope, that's what we're going to try to find. I'll put a little question mark there. And we don't know d, but because it's Pythagorean theorem, I'm going to be able to find d, right? And the d is 20. And it says it's increasing, so that's why it's a positive 20. You with me so far? So before I take the derivative of this, well, let's go ahead and take the derivative. So when we put the derivative in, that makes us add those rates of change in. So I have 2x dx dt. It's just for those we're gone, it's implicit differentiation. 2y dy dt equals 2 times d dd dt. You've heard of two special right triangles, like a 3, 4, 6, 8, 10. What do you think of 0.6, a 0.8? What would be the hypotenuse? 1. But if you didn't know, here's what we would do. If I would do 0.6 squared plus 0.8 squared equals d squared. 0.6 squared is 0.6. What's 0.8 squared? 0.64. 0.36 plus 0.64 is 1. What's the square root of 1? 1. So now I have everything but my unknown, what I'm trying to find. So we're going to plug all of the things in and solve for dx dt. So instead of 2 times x, I'm going to write 2 times 0.8, which is, 1.6. I don't know dx dt. Instead of 2 times, I'm going to write 2 times 0.6, which is 1.2 times negative 60. Equals 2 times 1, which is 2, and dd dt is times 20. All right, can you guys solve for dx dt? At 70 miles per hour, okay? Which also makes sense. I mean, the speeding car is moving away from the intersection, so its rate of change is positive. All right, any questions on that?